welcome to CBL. Now, very warm welcome to all of you. Let's have a look at the current affairs this week. So, to begin with, the issues which we are going to cover this week are Japan's Hayabusa 2 carrying asteroid rock lands Australia. Right, we are going to look into the matter. What is this Hayabusa 2 mission and why do we need to get the asteroid rock materials back on Earth? The next issue which we'll discuss is coronavirus IISc researchers working on COVID-19 detection using Raman spectroscopy and artificial intelligence. All of us know that coronavirus is still to be combated. So we need a number of tools first of all to detect this. So a new step in detecting this COVID virus is Raman spectroscopy. We'll look into this issue also. And now the next issue which we are going to discuss is World AIDS Day. India must gear up to end HIV AIDS. Now, on this World AIDS Day 2020, we had an important mission, but it somehow failed. So what are the implications and why did it happen? We'll have a look at this. Next issue which we are going to discuss is challenges in achieving herd immunity through vaccination. All of us are eagerly waiting for the coronavirus vaccine. But what are the major challenges that will pose a threat in achieving the herd immunity? We'll study them in detail. Moving to the very first issue, I'll take up the first news, that is coronavirus IISc researchers working on COVID-19 detection using Raman spectroscopy artificial intelligence. To combat any disease, we first need to detect and diagnose it. In our previous lecture also, I told you a number of tests are available for detecting this COVID virus. We studied about serological test, RT-PCR technology, RT-LAMP technology. Now, the researchers have shifted their concern to other chemical analysis. Look, whenever a disease happens to a body, any virus enters into a body, it does produces some biochemical changes. So, these biochemical changes can either be the cause of the disease or they can be the manifestation of that disease. So if somehow we understand those biochemical changes, we'll be able to fight that disease in a better way. Keeping this in mind, the researchers are trying to use Raman spectroscopy, a very important chemical analysis technique to understand this virus. And it will be compiled with used with the artificial intelligence. So that we can have a better understanding of this virus, and obviously then only we'll be able to combat this disease. So first of all, let's understand what is this Raman spectroscopy. Spectroscopy means in this process we pass the monochromatic light through a prism. A triangular shaped prism, a monochromatic light is passed through it and it splits into a band of light, a band of different colors of light. Now, what does this Raman spectroscopy do? It is implied to understand the basic chemical structure, the crystalline form of various biochemicals, be it low frequency DNA or some proteins. Now, first of all, it was implied only to understand the fingerprinting. This analysis was done used in fingerprinting technology. Now, we are trying to incorporate this very thing into the biomedicine and specifically the coronavirus. Once the monochromatic light passes through the prism, the photons scatter into a band of light. This is called as Raman scattering. Now, analyzing this spectrum using a spectrometer would give us an insight into the biochemical changes produced in the body. And obviously, if we know what are the changes, we'll be able to understand the cause or the effect of that particular disease. Raman spectroscopy, it is a non-destructive chemical analysis technique. As I told you, it was implied to study the structure. The various bonds present in the biochemicals, they scatter the light, scatter the photons, and this scattering is analyzed using a spectrometer, thus making this as a potent method to understand the structure. And our study, our ability to fight, to combat this disease would be much more if we understand the biochemical analysis. And what are the benefits of this using this Raman spectroscopy? This would obviously make our detection much more easier and hassle-free. We don't need any extraction process. This would just take care of the biomarkers present in the blood plasma of the patient. Right? Once we have those biomarkers in the blood plasma, no extraction required. These findings would be analyzed with the artificial intelligence, and an automated and rapid method would be evolved. So let's hope this research is successful and we'll have one more method to detect and diagnose COVID virus. Right. So I'll move on to the next topic, which is again very important. A major news that was present this week that was important is Japan's Hayabusa 2 carrying asteroid rocks lands in Australian outback. Now, before understanding this Hayabusa 2 mission, I must know what is an asteroid. Asteroid. All of us know that the solar system and the various planets, including Earth, was formed 4.6 billion years ago with a big bang. Right? So, during that big bang, a number of rock pieces were formed. Some of them condensed to form planets like our Earth. But still there are some rock objects and materials still present in the solar system which have not been condensed into the planets, and they are called as minor planets or asteroids. So basically, these are rock substances that are orbiting the sun and were formed at the same time when Earth was formed. So that makes them very important. That paves the path, that is the motive that why do we want to study these asteroids. Now, Japan's Hayabusa mission was to send the spacecraft to Ryugu asteroid. R-Y-U-G-U. We'll study about it in a while. First of all, let me tell you what are the three types of asteroids. We've got three classes of asteroids. The first class belongs to those asteroids which are present in the main asteroid belt between Mars and Jupiter. Right? A number of asteroids are revolving between Mars and Jupiter, and that forms a major chunk of the asteroids present in our solar system. Okay, the next class is of another important asteroids called as Trojans. T-R-O-J-A-N-S. Now, what are these Trojans? Trojans are those asteroids that share the orbit with some major planets. For example, in 2011, NASA told us about the Mars Trojan, the Jupiter Trojan, and Earth Trojan as well. So these Trojans are those asteroids which share their orbit with some major planets. Coming to the third class, which are near Earth asteroids. Now, our focus is to study these NEAs, which is near Earth asteroids. That means these asteroids have their orbits in common with the Earth. They are very near to the Earth's orbit, and they are about 10,000 in number, approximately. Out of these 10,000 asteroids, why did we have a mission on this asteroid Ryugu, because this Ryugu falls into another important category of NEA, that is PHA, potentially hazardous asteroids. Ryugu is one of those asteroids, PHA, potentially hazardous asteroids, which can pose a threat to Earth's existence. And basically, these are much more closer to Earth, so we need to study them. So, Japan's Hayabusa 2 mission was to study asteroid Ryugu, which has a diameter much less than 100 meters, and this was the first ever thing done in the history of space technology when a celestial body less than 100 meters of diameter was being landed and explored by a spacecraft. Right? So this makes Ryugu a very important asteroid because it is a PHA. Now, why do we want to study asteroids? First of all, they have origin just like our Earth, so we'll get an insight into the history of our planet. Moreover, these asteroids can be hazardous, so if we know them better, we can save our Earth. Right? So this was the mission. But this mission, before this Hayabusa 2 mission, there was Hayabusa mission which dated back to 2010. You can call it Hayabusa 1 or Hayabusa mission, which was launched in 2010, and the spacecraft landed on another asteroid called as Itokawa. After that, this mission was Hayabusa 2 was launched for the asteroid Ryugu. Right. Now, what did we do? In 2014, this mission started. Okay. It was launched in 2014 from Japan's Tanegashima Center, and there was an extensive 4 years study. It took 4 years to reach that asteroid Ryugu. It landed approximately July 2018. It was the first time it touched down Ryugu. And in 2019, a small explosion was done by this spacecraft to make a small crater so that the asteroid rock or land could be taken out from beneath it. Not only the surface materials, but it could be the dugout material which could also be brought back to Earth. And successfully it has returned on Earth on December 6 into the Woomera region, that is a military base camp in southern Australia. From there, it would be taken by Japan's exploration agency, that is JAXA, Japan's Aerospace Exploration Agency, JAXA. And some of the material would be given to NASA as a pact so that they can also study the materials brought back from Ryugu. So that makes it a very important mission. And most importantly, the thing to be noted is that this mission is not ended here. The spacecraft is set to move to another asteroid, that is 1998 KY26, which is set to reach there in coming 10 years, 2031. So Hayabusa mission is still continuing, and in 2031 it would land on another important asteroid, that is 1998 KY26. And we wish to study these asteroids to get a better insight into how the Earth was formed and what are the potential hazards that these asteroids can pose to the Earth's survival. Right. So this was all about the mission. We move on to the next issue, that is World AIDS Day. India must gear up to end HIV AIDS by 2030. All of us know that post December is AIDS Day. We missed a mission. By 1st December 2020, it was decided that this HIV AIDS spread would be ended. But it has not been achieved. all of us know that because of this coronavirus pandemic, our center of thinking of the whole medical field has shifted to this coronavirus. So somehow the mission could not be realized. So before starting this in detail, let me tell you what is actually AIDS. All of us know AIDS is acquired immunodeficiency syndrome, which is caused by a retrovirus HIV. Retrovirus, as I told you, it is a virus which has RNA as its genetic material. Now, what does this virus do? Once it enters the body, it attacks the lymphocytes of our body, named as CD4 cells. So you must remember that CD4 cells are the lymphocytes which are responsible for providing immunity against all the viruses and the foreign objects that enter our body. Now, once this virus attaches to a CD4 cell, it controls it, and the RNA of this virus binds to the DNA of this cell and increases its own production. And this is called as viral load. That means having much more copies of that virus. This is called as viral load. Now, once this viral load is there in the organism or any human being, it lowers the immunity. You will be surprised to know that actually a person doesn't die of AIDS. The mortality is due to other optimistic infections. Since the immunity is lower, even smaller infections like influenza, cold, herpes, and even pneumonia can cause death. Why? Because the CD4 cells have been infected and they do not no longer provide immunity to our body. So, because of optimistic infections, which is OIS, optimistic infections kill the person having HIV. So a person doesn't die of AIDS actually, he dies of AIDS related diseases. Now, what is this mission? Why have we failed this mission? We want that the viral load should be reduced. That means somehow we increase the number of immunity providing cells, that is CD4 cells, and side by side we should always also try to decrease the viral load. And this can be done only through antiretroviral therapy, which was launched in 1996. Now, what is this antiretroviral therapy? It is a therapy where we combine 2 or 3 drugs to increase the chance of survival of that particular organism or human being having this virus. Right? 2 to 3 techniques, 2 to 3 drugs are actually given to a person to increase the chances of survival. This is antiretroviral therapy, and it works in a twofold manner. First of all, it tries to increase the CD4 cells, as I told you. Side by side, it tries to reduce the viral load. Reduce it to such a level that we achieve a concept called as U is equal to U. That is undetectable and untransmittable. Right? That means the viral load has reduced in the blood to such an extent that it cannot be detected, and if it cannot be detected, it is such a low level that it cannot be transmitted to another person. And this is the reality that we want to achieve. This is a mission in our mind. But we have failed in 2020, but we aim to realize this by 2030. By 2030, what do we aim to do? 3 things we want to do. That is, we must analyze and collect the data of 90% of the people that are living with HIV, that is PLHIV, people living with HIV, 90% of them should be aware of their infection. Out of those 90%, we have to give ART, that is antiretroviral therapy, to another 90%. Out of this 90%, 90% of them must receive ART. And those who receive the ART, out of them again we aim that 90% of them should have viral suppression. Now this makes it a 90:90:90 concept. That is, first of all collecting the data and making them aware, 90% of the people living with HIV. Out of those 90%, again we have to give AR to another 90% people, and those which receive the ART therapy, 90% of them have viral suppression. So practically what we are trying to do is, we are trying to lower the viral load so that it is undetectable and untransmittable. But somehow this mission has not been realized, but we are aiming at December 1, 2030. So this was the main news. Apart from that, I want to share some information regarding the National AIDS Control Organization, which was set up to control and prevent AIDS in India. So the program, National AIDS Control Program, was launched in 1992. Long back in 1992, it was regarded as a taboo that if a person is HIV positive, we must not sit with him, we must not have food with him. So all these sort of things which made him a socially secluded group of people, this was to be avoided. So it was launched for prevention and control of HIV AIDS in India. Under this, 4 programs have been launched. First of all was in 1992, NACP1. With an idea to slow down the spread of HIV infection as to reduce the mortality. The mortality rate was very high, but because if anyone had this infection, if anyone was HIV positive, they did not want that anyone should get to know about this, because they'll be socially secluded in the society. So first of all, the thing was, we had to make them realize that it is another disease and it can be cured. They had to bring it to the notice of the health officials. So this was the primary concern, slowing down the spread and so as to slow down the mortality and impact. This was the first program, NACP1. Then there was NACP2, which was launched in November 1999. Again, the motive was to reduce the spread and to increase India's capacity to respond to HIV/AIDS on a long-term basis. Any country, if has to combat a disease, it must be prepared for it. So, the second program aimed to prepare India to fight this disease, this infection. The third phase was launched in July 2007. With the goal of halting and reversing the epidemic by the end of project period. Now, reversing the epidemic, that means whatsoever is the number of the HIV positive patients in India, it should not increase, rather we should reverse the epidemic. And this was not realized in the third phase. The fourth phase was launched to fulfill this goal, to reverse the epidemic, and that was that we should have U is equal to U, undetectable, untransmittable, and we should end it by 2030. So it's still going on, the fourth phase is still working, and we have different components of NACP4, which are, first is intensifying and consolidating prevention services with a focus on HRG. Now HRG is high risk groups. All of us know that AIDS is transmitted by a sexual contact with an infected person from the infected mother to the child, and it is most common in sex workers and the drug abusers. So these are the high risk groups. We need to educate them and we need to provide them IEC, that is information, education and care. So the second component aimed at expanding IEC services, educating them, informing them and then giving them care for general population as well as high risk groups. The third component is strengthening the institutional capacities. The hospitals and the other institutes or the NGOs they are working for the eradication of AIDS must be strengthened. The fourth component was strategic information management system. We had to collect the data, manage it properly. Then only the fourth program could be realized and we can achieve this goal, eradicating it by December 1, 2030, which we have failed so far, but it is planned to be done by December 1, 2030. That's the major issue that is being focused this week. Now moving to the next issue. Next is challenges in achieving herd immunity through vaccination. A hot topic again. We are all waiting for the vaccine to be brought into the market so that we can be vaccinated and we are free of this pandemic. But basically, what about breaking the chain? Breaking the chain of transmission is not possible if we vaccinate only a few people. Herd immunity means that if we vaccinate 70% of the population, there is no need to vaccinate the rest of the population. But is it okay? Is it right? So there are a number of challenges. Would it be wise enough that whole of the population is not vaccinated? So a number of challenges are there. As per the Director General of ICMR, that is Dr. Balram Bhargav, if we are able to vaccinate a critical mass of people and break virus transmission, then we may not have to vaccine the entire population. Again, a big question mark, because there are other views also that it cannot be achieved. Now, what are the major challenges? Why it can't be achieved? Why the herd immunity can't be achieved? First is uneven transmission. Now, if I talk about SARS-CoV-2 virus, it has got an uneven transmission. Some people are severely affected by this disease, while others do not show any symptom of this virus and they become as silent carriers, right? They can transmit, but they are themselves not affected. Okay, so also we are waiting for the Oxford vaccine, and it has been confirmed that 2 doses at least are to be given to combat the viral infection. So considering that 2 doses of the vaccine are needed for prevention and increased vaccine hesitancy, how is it possible to break the chain and obtain 70%, because India is a vast country? So giving 2 doses, again, it is something which is a major challenge. The next challenge is aim high. Why only a few people to be vaccinated? Why not the whole community? We must aim high as per one of the major challenges, that we are to cover all those people present, and we must aim for a bigger chunk of the population as a major target. Again, this thing has major implementation challenges. Right. Next challenge is ethical challenges. Why should I say that only these people should be vaccinated? This shouldn't be. It should be publicly approved, and moreover, there must be a logic, a rationale behind why only this person is to be vaccinated and not this. Again, not providing vaccine will hinder the other vaccination programs that are being carried out by the government. So ethical challenges obviously a bigger role to play. Apart from that, a major conflict is that what about the people who have already suffered from coronavirus infection? Is that immunity good enough for them to be saved from this reinfection? The first point says yes, they have got immunity, so they need not be vaccinated again. At the same time, the results are still to be updated. There is no evidence that a person who has already suffered from the coronavirus will not get the infection again. And moreover, if they are being vaccinated, is it okay that they should be given vaccine because the immunity system has already been lowered? What about if the vaccine given will produce some major hazards to the body of the patient? The person who has survived the first infection. So the question mark is still there. We are still waiting for the evidences, and that the person who has already suffered should be given the medicine or shouldn't be. So major challenges which need to be studied. So we have to wait for a bit longer to get this vaccine. That's all for today. I'll see you again. Thank you.